it's a very sturdy design. It keeps it very firm. For example, the bottom beam. It prevents it to vibrate to go any other side. So it goes straight instead of going anywhere inconsistently. And for this, the top beam is for the arms. When you want to rip off the arms, it can't go upwards. This thing is blocking it. It can't go upwards. So if you like rip off the motor, it won't stay there. So it's designed for quick change.
We have a light sensor attached to the bottom. This serves three purposes in the course. The first purpose is to guide the robot back to base as it moves along. In our design, we bring the robot over here, and as it turns around, the light sensor will detect the black line. It then moves in a zigzag pattern and returns back to base. The second design for our light sensor is used to detect this black line. After it detects that black line, the robot will automatically move backward to allow space for the arms to go down and collect the three loops. The third purpose for the light sensor is to detect the black line on the far side here, near the dynamo. Once it detects this black line, the robot will move slightly towards the right, and it will knock down the access marker. Yes. All right. Maxi, could you please explain the phrase?
Use a bigger wheel because if we use a smaller wheel, it won't move at all. Because here is a very bottom. We turn it by if we took out this rubber, it's the same thing. It won't move also. We turn it by using a tank blade. If we round it together, it will just go straight. If this went faster, it will turn.
So there are only two wheels.
Yeah. We add the wheel in the side wheel to make it go straight inside here. And we choose to add this stuff to reduce the friction. We don't want to use the caster wheel because it's much harder to turn. We found it very hard. So we use this. Okay.
We have some batteries inside here, and according to our experiments, the robot can only complete its task when it is on 8.3 to 8.4 volts. And if it goes below 8.3, we have to take the extra batteries we have that we charged with it and put it inside so that it can complete its task.
What's the original voltage?
8.5, around 8.5.
This arm is to connect the first two loops, and this arm is to connect the ground over there. This thing is attached to the side of the robot. We designed this whole arm to connect the loops on the map. This arm on my right is to connect the blue loop over there, and this in the middle, this tree arm is to get the loops, three loops over here. And this tool is for emergency. So when it misses the hole on this long one, it enters this tool. The one on my left is to collect the gray loop over there. And down here this one is to support this whole arm so that it wouldn't fall too low.
So how many missions you have altogether?
We have 3 missions.
Would you like to show one of them?
Can you demonstrate?
Yeah, demonstrate one of them.
Would you like us to run the robot manually using our hand or actual program?
Actual.
We can't really possible because we have two robots, and this is just our model which we work on for the arms. The actual robot programming is in another module.
Okay.
Yes, sorry.
So then you show us by hand.
We can show you.
For mission 3, it will just go here, and then we give it a nice turn here.
How does it know when to turn?
We have programmed using hard coding. We have programmed using hard coding. We tested a lot of times, so it looks successful.
Okay, so it's measure it lah.
Then it turns here to the wall. Then when it touches the wall, it makes a pretty nice turn here.
Then the tire will help and twist it.
See, it turns. And then it goes straight
Why
inside.
does it turn left to come around?
To make it, we just let it turn to make it accurate into that. If we go straight inside, it may hit
Yeah,
this
why
one.
not turn right?
Because we need to align the robot to the wall. There's a side wheel by the side, and this so that when we turn the wheel will automatically align the robot, and it can move straight forward.
Okay.
Okay, then it moves. But if you don't add this thing, the tire will hit it and will stuck there. So add this stuff to move it. Okay, here.
And then it will hit
It
the
will use a
access
laser.
markers.
It will be a light sensor. It will hit here, access marker. It will go straight, hit the wall. It will hit the wall, make sure it stays there. It will hit the access marker. And then it will turn back. Turn back.
The light sensor will detect the line here, and then it will make a fixed distance there, and then it will hit these two.
And that's enough option.
Okay, so that means your line sensor is mainly just to detect that
The
you cross the line,
Yes.
Yes.
rather than actually
It's-
to follow
No,
the line.
we did use it. We did
use
use it over here, but
Okay.
as we have found out, it really slows down our time because it needs like really detect the line. So it takes a lot of time. So we prefer to use hard coding to detect.
Have you tried any other sensors?
We have tried distance sensor for the walls, but that was simply too difficult due to the time we had, and the light sensor didn't good enough. It was unnecessary. It was just overcomplicating the design.
From start until now, how much time you have spent on this robot?
About 3 to 4 weeks because we had very little time. The sets arrived late for us.
I see.
We had exams.
We also had
Minus 1 week.
So all of you were